Now we can add errors. Let's say we have two measurements. Suppose we have a book. For example, let's say I have one book, and this book, I measure the thickness of this book, and I find that the thickness is okay, let's say 15 millimeters, right? I've measured it using a ruler, a simple ruler. Now I have now another book. Okay, I have another book. I'm just going to put this book on top of the other one, right? I have this book here. Now I've measured the thickness of this book separately. Okay, measured it separately with the same ruler, and I found that the thickness of this book is actually 13 millimeter. Now, let's think about the errors in my measurements. Now, the ruler that I used, is a simple ruler which is graduated in millimeters. Now, what that means is I have a ruler, just a simple ruler that we can buy from the shop, and this ruler has marks on it that goes with a mark at the start and goes 1, 2, 3, 4 little marks, and then 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And this would be 0 centimeters, 1 centimeter, 2 centimeters, and so on in cm. Okay, and each little interval here would be 1 millimeter. 1 millimeter. Now, when I use this to measure the thickness of the book, I'll find that the book does not always lie on, the thickness of the book will not always fall exactly on one of the mark. Let's say if I put my book, the two edges of my book here, let's say I have this book, for example. Now I might hold the book here. Okay, when I measure it, 15 millimeters will be until about there. Okay, I hold this part of the book here, and I'll measure from 0 millimeters to say 15 millimeters. But I find that the edge of this book need not actually lie exactly on the 15 millimeter mark. It might be a little bit to the left or a little bit to the right, and I'll just have to make the best of this and take the line, the marking which is closest to the edge of the book as my reading. In this case, I will take this. Okay. Now, how would I decide the closest marking? Well, I'll just look at this edge and see whether it's closer to this or to this, and that means that it is there's sort of a dividing line which is halfway between the two marks. If it's to the right of that, I'll take this mark. See, if right, this mark here and this mark there, and I want this edge of the book to be that when it's closer to this mark, I'll take this mark. So the halfway line here would divide the two marks here into half. So the distance from the halfway line to halfway point to this mark is 0.5 millimeter. Okay, so as long as this edge is within half a millimeter of this mark, I'll take this mark as my reading, which is 15 millimeters. But what this means is that I won't know exactly where this is. I can only know it to plus or minus half a millimeter of this mark. So that gives me my error. All right, this means that for this 15 millimeter reading that I have, which is the best that I can do, there is actually an error of 0.5 millimeter. Now we write this down by using this plus or minus symbol. So it can be plus or minus 0.5 millimeter, means within either minus 0.5 or plus 0.5 to 15 millimeter. And the same thing happens when I measure this other book and find it's 13 millimeter. So really, there has to be some kind of an error, because the markings are always 1 millimeter apart. We can seldom be exactly on the right marking. So there would also be an error there of plus or minus 0.5 of a millimeter. So that's the best we can do with a ruler, really, unless we use something more accurate, like the vernier calipers. But in this case, if we are using the ruler, all right, this is the information that we have. All right, both thickness values have some errors. Now the question now is, if I stack one book on top of the other book, what is the total thickness? One book on top of the other book. Now I am interested in what the total thickness is. Now, but I don't want to have to measure this again. I just want to make use of these two numbers and calculate what this is. Well, clearly we should add the 13 and 15 millimeters. Let's do that. 13 plus 15, okay, that gives 28 millimeters. So that's fine. But what about the error? Now I have, I know that since each of this number came from those two, which have some errors, my answer of 28 millimeter can't be an exact answer. There must be some error. But what? So what is this error? Can I just add the two errors together, or will they cancel each other out? But the way to do it is like that. Let's look at, say, the 13 millimeter value. Now this is 13 millimeter plus or minus 0.5 mm. So to the best of our knowledge, when we say 15 millimeter plus or minus 0.5, that means that it can be anywhere between 13 minus 0.5 and 13 plus 0.5. So that means say 12.5, anywhere between 12.5 to 13.5. So likewise for the 15 millimeter reading, it can be anywhere between 15 minus 0.5 and 15 plus 0.5, and that would be anywhere between 14.5 to 15.5. And so therefore, what we can, from these two, we can actually say something about the final answer of 28 millimeter. We can say something about the possible range of values. Now we can start with the smallest possible number for this, and we would get that simply by adding the two smallest possible numbers here. Alright, the smallest possible number for this reading and for this reading. So for this one is 12.5, for this one is 14.5. So if you add those two, we get for this let's see, so that will be 26, 27, right? 27, 2. And then the biggest possible answer for adding those two would be to add those two values, right? The biggest possible value for each one, and that would be 28, 29. 27 to 29. So 28 is, this answer is really between 27 and 29. That's the smallest possible value of that, and that's the biggest possible value of this, and this is the smallest possible value of this. And 28 is obviously in between, exactly midway between those two numbers, and those two numbers are 1 millimeter on either side of this. So therefore, this number here must be 1 millimeter. So plus or minus 1 millimeter. Now this is a rather long way of doing it. We have to work this out, and then work out what this is and what that is. There's a much quicker way of doing it, and that is simply to go back to the original values and errors and take the biggest or take the most positive values of the errors, because meaning the plus 0.5 and the plus 0.5, because it is the positive values that gave rise to the bigger of the numbers here in each of this range. So all we need is to take the 0.5 and the 0.5 and add them up to get the 1, and that gives us the error. So in this way, we have a simple way of finding the error, the combined error of adding two readings. All we need is to add the errors together. Now this method works when we have when we add two numbers, and if we know the error of the two numbers, then we can simply add the errors to give the error of the final answer.